Welcome back. Uh, Today we are going to discuss about different data types used in Java. Though I have done to a small extent this particular topic prior to this class, however, we are going to get into more, greater details in this particular chapter because a lot of theoretical aspects of this particular chapter comes under section A. So we have to take it, seriously into consideration. Uh, Although I know that you are much more familiar with programming, but you cannot leave this theoretical aspect of the particular subject because 40 marks depends upon this, and this particular chapter is very important, and there are a lot of questions which are related to this particular chapter. So we are going to see this and this particular video and compare to the videos which had got prior to this, where I had given a video separately. Along with that, I had given notes. Out here in this particular video, you need to be very careful. First of all, there'll be the contents being displayed on the screen, no doubt regarding it. Along with that, I'll be explaining certain things which are there on the screen and off screen. So you need to be very attentive this time while viewing this particular video. So all the best. Let's start with this, and of course at the end we'll have the assignments as usual. Okay, so the first thing what we are going to discuss is character set. I believe we have already done this. So here what we are going to do is we are going to define character set. So what is a character set? A character set is a set of alphabets, letters and some special characters that are valid in Java language. So whatever alphabets, letters, digits, symbols, whatever is being used to write a Java program, that forms the character set. So there are a few examples over there. Letters, what are the letters you can use? So capital A to capital Z or small a to small z, digits from 0 to 9, symbols, look at the symbols, percentage, ampersand, caret symbol, at the rate, dollar, pipe in symbol, all sorts of symbols are there. In course of time, we'll be learning more different symbols. Anyway, so character sets are all possible characters that may be used in a Java program. Next, you see over here what is written on the screen. Every character in a character set is mapped to a set of non-negative integers. So for every character that may be used or represented in a program, you have a corresponding number associated with it. This number is integer, it cannot have decimal point. Thus, every character is represented by a number in the computer system. Obviously, because computer is a number crunching device. Remember the binary number system. This number is called the code for that particular character. So this is a kind of an encoding technique. Encoding technique in the sense that for every character there will be a number to be represented in the computer. Of course, internally that particular number will be converted into binary. You know that computer understands only binary language. So it will be converted to binary and then represented internally. So this particular system is called encoding. So a number of encoding systems are available for characters in different languages, like ASCII. You see the full form of ASCII, American Standard Code for Information Interchange. So there are different encoding techniques which are used with different languages. ASCII is used in older languages like C, C++, though the relevance is still not lost. There are certain languages which still uses it. ISCI, Indian Standard Code for Information Interchange. So there you can find ISCI. That's one more encoding technique which actually incorporates all the scripts or the letters of Indian dialect. And then what do we have? We have Unicode, one of the most popular and most important encoding technique. Of course, Java uses the Unicode system. So every character set in Java uses the Unicode system, and you can see the full form over there, universal code, which itself tells everything. Basically, a Unicode is a encoding technique that is used to represent 65,536 characters, which includes characters of almost all the languages of the world. So you can really imagine. So ISCI, Indian Standard Code for Information Interchange, already lost its importance. ASCII, uh, you know, it keeps its legacy, but hardly it is being used because people are concentrating more on Unicode because it's more familiar to the local languages over there. So you can find the output which you get in Java may not necessarily be in English. It may be in Hindi, it may be in Bengali, it may be in Tamil, it may be Telugu. Think of any particular language in the world, it's already there with Unicode. So such big is the scope of Java. You can understand, I believe this. Okay. Now in the ASCII code, you can see ASCII is an encoding standard that assigns letters, digits and other characters with unique numbers starting from 0 to 255. So altogether you can represent only 256 characters as a 8-bit code. So it's a 8-bit code where you have to understand this, that uh, only C++ language, perhaps some of you have already done before the C++. So in that particular language, we use the ASCII code system. And remember, uh, the first 31 ASCII codes represents control characters. That is different type of controls, that is backspace, escape. So these are different as control characters are represented using that, the first 31. From 32 to 127 is used for representing different characters. So out there includes capital letters, small letters, different symbols like question mark, greater than, less than, all these symbols. And from 128 onwards till 255 are for characters which are specific to a particular computer system. So each computer system may be different from each other. What is important to us is that is we need to remember the ASCII code for capital letters, small letters and digits. For capital letters, please remember it is 65 to 90. Please note it down. For small letters, it is 97 to 122. For digits from 0 to 9, it is 48 to 57. So you can understand, this particular ASCII codes, that is first 127 ASCII codes, is same as Unicode even. So if you remember this, you also will be remembering the Unicode system, because you will be asked questions related to only English alphabets and nothing else. So even for Unicode, the capital A to capital Z is 65 to 90, small a to small z is 97 to 122. Similarly, digits from 0 to 9 is 48 to 57. So now you see this particular ASCII code has been categorized into 3 groups: non-printable, starting from 0 to 31, that is 32 characters; lower ASCII from 32 to 127; higher ASCII, beyond that, that is from 128 till the end. Lower ASCII is where our capital letters and small letters are present. And Unicode, here you can see it's an international encoding standard for use with different languages and scripts, by which each letter, digit or symbol is assigned a unique numeric value starting from 0 to 65,535 as a 16-bit code. Remember, ASCII code used 8-bit and here it is 16-bit. So that means it's 2 bytes that applies across different platforms and programs. So making it truly universal. Now we'll get into tokens. I believe we have already done this, but still we'll go through it once again. So token is the fundamental building block of a program that represents a single element of a programming language. So any single element of a program is represented by a token. And here we have the different types of tokens. So what do we have? Keywords, identifiers, literals, punctuators, operators, and finally, which is not universally accepted, that is white space. White space are blank spaces which we vigorously use in our program to increase the clarity of a program. Sometimes it is even the syntax of it. So it is a valid token, but there are several authors who do not believe it to be a token. But white space is a character and it is a token. So total there are 6. However, keeping into view our curriculum, we'll talk about only the first 5. That is still punctuators from keywords. So all these 5 leaving white space are valid tokens in Java. So keywords, that's the definition for keywords. A keyword is a reserved word that have a specific significance to the compiler. Which compiler? Here it is Java compiler, and cannot be used anywhere else other than what it is intended for. So whatever it is intended for, like you had been recently doing programs related to for loop. So for cannot be used for anything else other than what it is intended for. So keywords are exactly that. They are reserved word. They have a specific meaning to the compiler. Java, please remember this, the last point, the Java has 50 keywords. There are 50 keywords in Java. And you can see, all these 50 keywords, and you can see two blank, I believe you can see two blank, with the mouse pointer I'm showing you just below the for and just below the class. So there are few blanks out here, only two blanks. And I have a reason why I kept it blank. So you must have seen, go to coming jumping from there. And what do we have? We have const, const. Now please remember these two keywords, that is go to and const. These two keywords, they are a bit funny, in Java. They have kept these two words. That means they are reserved. You cannot use for anything else. However, it does nothing. So go to and const are two keywords which does literally nothing. And please remember something that, the keywords null, true, false. It seems like a keyword, but are actually literals. So null, true, false, even these are like keywords because they are reserved words. You cannot use it for anything else, but basically they are literals. We do not consider it to be a certain command to do a particular job. So they'll be considered to be literals, not keywords. Please do not get confused. In Java, we have just 50 keywords. That's it. Now identifiers. So now what are identifiers? Identifiers are the names of variables, methods, classes, packages and interfaces. So identifiers basically are the names given to different parts of a program. It may be a variable name, it may be a method name, it may be a class name, it may be a package name, and it may be a interface. Now there are certain rules which you have to follow for using identifiers. So what are the rules? It can have any alphabet, capital or small, digits, underscore, dollar sign, characters. So few examples are also given over there. You can see it should not begin with digit. So you cannot have a variable, beginning with digit. Only you must have seen in the first 2 points, there are only two symbols which are allowed, that is underscore and dollar. So these two symbols may be used in a variable. But apart from that, nothing else. And remember, only you should be using alphabet to begin a, identifier name. And next, look at the third point. It cannot have a space between it. So, for example, simple space interest, there is a space, or selling price are invalid identifiers as it contains a space. It must not be a keyword like for, while, do are invalid keywords. Why? Because they are, keywords. They cannot be identifiers. And lastly, it can be of any length. The length of an identifier can be infinite. However, it is quite useless if you use too, long. It is not practical at all. Now, there are certain conventions which you should follow while using identifiers. Please remember this. This will be requiring when we, start thoroughly, using, write programs for section B part. We need to follow certain conventions. You see, do not get mixed up. Conventions are not ruled. They are actually, universally accepted agenda. You can think universally accepted agenda which is accepted by every programmer in the world. So even the ICSE council wants you to follow certain conventions while using identifiers. Now what are they? Look at the first one. Names of methods and variables should begin with lowercase letters. So you can see over there sum, marks, count, etc. So name of methods and variables should begin with lowercase letters. So all those variables and methods which you'll be using should be in lowercase. Class name should begin with capital letters. Look at that example. So a class name should begin with a capital letter. That's a convention. Do not mix up that it's a rule. No, it's a convention. It is universally accepted, an agenda. And then what do we have? If method name, method in Java means the function. You had been, writing programs related to the assignment which I had given, and all these programs you had given the name main. However, you can give any name, and this, main is basically a function. So here what it specifies is if method name, variable name or class name consists of more than one word, the first letter of each new word should be in uppercase. So that means from the subsequent, you see, first of all, you need to understand that we cannot have a blank space in the identifier. So if it consists of two words, basically you have to keep it together. Now the problem is if you keep it together, how will you differentiate between the two words? So what we do is for subsequent words, first character should be written in capital letters. So there are a few examples you can see over there. Example, you can see class names. Class names, we already know that it should begin with capital letters. So my class. So M and C is in capital. These are two words but cannot have a space in middle, and it is written that way. Similarly, account details, you can see A and D is written in capital. When it comes to method names or variable names, how do we write? You see over there, average of numbers. We can easily read it out. Have you seen it? See, look at the way this convention has been done. It is easily readable. And method name and variables name, you know that it should be beginning with small letter. Hence, it is written that way. And similarly, sum of even numbers, you see it's written all together. However, from the second word onwards, the first letter is capital. And next, what do we have? Constant names should be in uppercase. So all constants means they are constant names, means there are certain variables in Java which you can, declare, whose value cannot be changed. So such variables should be written in capital letters. So few examples are given over there. Now literals. Now what are literals? I had already talked about literals. Literal is a constant value that can be assigned to a variable. So different type of literals, integer literal or fixed point literal. You see that's another name for integer literal. And then what do we have? Floating point literal. Then we have Boolean literal. Then we have character literal. Then we have string literal, a group of characters. Remember, null literal and class literal is beyond the scope. So I cannot discuss much of this right now. And now let me talk about a type of character literal which we call escape sequences. Now what are escape sequences? Escape sequence, also called escape characters, escape codes or backslash character, in general are used to signal an alternative interpretation of a series of characters. So in Java, a character preceded by a backslash is an escape sequence and has special meaning to the Java compiler. So here are a few examples you can see which can be used in BlueJ. That is backslash n for new line. That means if you want the cursor to come to the next line. Then you have backslash t for horizontal tab space. With every tab space, remember the next data will start from the 16th column. Please remember that. And then we have backslash single quote. In case we want to display a code, it should be preceded with a backslash. Though the current version of Java allow a quote to be displayed within the double quotes also. But however, we have a problem in case I want to display double quotes. That should be preceded with a backslash. And if I want to display a backslash, we have to write two backslashes. Otherwise, only one will, otherwise it will not display at all. So here are a few examples you can see over there. Look at the way it is given, hello and then backslash n. It will ensure that the cursor goes to the next line. So from is displayed in the next line. Similarly, backslash n, again the cursor goes to the next line and Java gets displayed. Similarly, first backslash t, a horizontal tab space, two horizontal tab spaces, we have backslash t is second. So it is going to print the first, and after that leave for every tab space we have 16 columns. For the first tab space it will start from the first column, it will go till the 15th column, and from the 16th column the second tab space starts, and again you add 16 to it, so it's 32. From the 32nd column the third tab space gets displayed. So you'll get a lot of blank space between each one of this. And then you see I love computers. If I want the love to be enclosed within quotes, double quotes, look at the way it is prefixed with the backslash. So that is what we get in the output. You can see on the right hand column we have the outputs, and left hand columns the statements. And in case I want to display the backslash, I have to write double backslash, otherwise none of the backslashes will be displayed. And then we have the next token, that is punctuators. Punctuators are also called separators and has syntactic and semantic meaning to the compiler, but the exact significance depend on the context. So each one of the punctuators have different type of meanings. You see semicolon, which you have already come across, it is used to mark the end of a statement. Here you can see the first parenthesis. I'll show you with the help of the mouse pointer. This is the parenthesis. The parenthesis, you have already seen that in expression, mathematical expressions. Then we have the braces. The braces is used to mark the block in function and class. This is basically the third bracket, which you can see over here, is basically used with arrays. Then we have comma, then we have full stop. So all these different punctuators have different meaning. It changes according to the context. And then we have data types. So data types are a way of dictating Java what kind of data your program is going to use. So it is defined as Java uses data types to identify data and dictates the method of handling it. So what are the different type of data it will be used in a Java program is all dictated using this data types. Now you see this data types is categorized into two groups, that is primitive and reference data type. So in the primitive data type, these are inbuilt. Please remember, primitive data types are inbuilt, and you can see a few primitive data types: byte, short, int, long, float, double, char, and boolean. So all these are primitive data types. So we have 8 primitive data types. These are inbuilt within the language. And then we have reference. Reference are also called composite data type, by the way, and primitive data type are also called fundamental or intrinsic data type, and reference data type is also called composite or extrinsic data type. Now for reference means, which we'll study later on, it represents classes, arrays, interfaces. So all this comes under this particular data type. Now let me talk about variables. Variables, I believe you already have come across this in your lower classes. It's a name given to a memory location. So that's how we define a variable. A variable is a name given to a memory location that can contain a data value. Now you see this part example, you see how we declare it. Int a, what does it mean? That means a is a variable of int data type, that is integer data types. Float c comma d. So c and d are two variables of float data type. Remember, float is used to represent numbers with decimal point. Char e, so we have a variable e to represent a character. And next, what do we find? A constant is a value. Now here you see something very interesting goes on. A constant is a value that cannot be changed. Example of integer constants, you can see over there few examples. No commas are there, don't mix up. These are all different examples. Examples of floating point constants, you can see 4.642, that means with point. So variable initialization in declaration, you see int c equal to 245, that is called initialization of variables. So whenever we declare a variable, so you see this example shows you declaration, that is telling Java that I'll be using a variable a of int data type. Remember, in this context, let me tell you that Java is a strongly typed language. Strongly typed language, what does it mean? It means any variable that you are going to use should be declared first. Declared first in the sense that you need to tell Java what type of variable you'll be using. That means you declare a variable, you need to tell what type of value it is going to hold, whether it is going to hold an integer or a character or a number with a point. So that is why Java is called strongly typed language. Now here you see the variable initialization in declaration. You can see over here, how do we initialize during declaration? This is the technique. You can see over there character variables being initialized, boolean variable being initialized, a variable of double data type is being initialized. Next, there is something very interesting. I was already talking about this, that in case we want a variable to be a constant, we call it a symbolic constant. Symbolic constants in Java are named constants. That means instead of constants which you can see over here, these are fixed numbers or fixed letters, these are named constants. That means, in other words, these are variables whose value cannot change. So how do we do that? Final double pi equal to 3.142. Now you see I have declared a variable called pi whose value is 3.142. It will remain throughout the program, and you cannot change the value of pi. That means you cannot increment the value of pi, or you cannot change the content of the pi equal to 2. You cannot write that. It will remain fixed throughout the entire program. And remember, I am following the convention. Since I am declaring a constant, and remember I had specified prior to this that a constant should have all the letters in capital. You must have seen that. So this is the reason why I have declared this particular symbolic constant with both the letters capital. And there is one more interesting thing. We will be able to represent numbers with scientific notation. You can see over there, scientific notation is another way to write a number. In scientific notation, the letter E is used to mean 10 to the power of. For example, 1.314 E plus 1. What does it mean? 1.314 into, that's 10 to the power 1. This is actually power 1. It's a slight mistake out there. It's 10 to the power of 1, which is 13.14 actually. Now look at this, double A equal to 12E3. What does it mean? It means 12 into 10 to the power of 3. What does this mean? 12.5 into 10 to the power of minus 5. So I believe you can understand how scientific notations are written in Java. There. Now we are going to discuss the different data types. You see, the first data type, that is primitive data type, which we use in Java, is integer data type. So what are the different integer data types used in Java? Byte, short, int, long. So these are the different 4 possible integer data types which can be used in Java. Now the question may arise that why did they create 4 different types of integer data type? They could have just given long, but it's because it's good enough, can accommodate any kind of integer. The reason behind this of categorizing integer into 4 different segments is because of the requirement. Say for example over there, byte, you can see the range. The smallest possible number that you can store is minus 2 to the power 7. Can you see that? Minus 2 to the power 7, and the largest possible number you can store is 2 to the power 7 minus 1. So that means if you do not have a very large number, what is the point in taking long? You will be wasting memory. That is why you see all this integer data types, it has been categorized into different segments. So first one is obviously byte, which is used to represent numbers ranging from minus 2 to the power 7 to 2 to the power 7 minus 1. It's of size 8 bits. You have to learn by heart, because you will get questions like this. What is the largest possible number that can be stored in short data type? So it will be 2 to the power 15 minus 1. Similarly, what is the smallest possible number that you can store in int data type? That is minus 2 to the power 31. Similarly, what is the largest possible number that you can store in long data type? You have to tell that 2 to the power 63 minus 1. So that is how we tell. Next, we have the float data type. There are 2 categories over here, float and double. Float, you can see 3.4 I believe you understand the scientific notation, 10 to the power minus 38 to 3.4 into 10 to the power 38. And similarly for double, which is huge, 64 bits, it's whooping, 1.7 into 10 to the power 308 minus 308 to 1.7 into 10 to the power 308. So it's a huge, range out there to represent double numbers. And character and Boolean data type will go through this. Character, it's a 16-bit. Remember, ASCII uses only 8 bits. Java uses Unicode, so that is why it's 16 bits to represent characters, and the Unicode's range is from 0 to 65,535. And Boolean consists of 8 bits, which can represent either true or false. Now we are going to understand one more subtitle out here, that is called type conversion. Type conversion is the process of assigning a value from one data type to another. This is particularly useful in mathematical expression. For example, when I add a float type number with an integer type number, so what do you think is the result? Of course, to be correctly at evaluating it, the answer should be of float type, because when you add an integer with a float, the answer may be in point. So that means the variable on the left hand side of the equal to should be of float type. So all this, what is the resultant data type? This comes under this particular category called type conversion. And there are two types of type conversion. You can see over there implicit type conversion and explicit type conversion. Implicit type conversion is done automatically by Java. And explicit type conversion, this is entirely done by the user or the programmer. So what happens with implicit type conversion? You can see over there a data type of lower size occupying less memory is assigned to a data type of higher size. So higher data type, that means the size in bits or bytes. So a data type of lower size, you can see that in example. You see int x equal to 10. So x occupies how many? Since it is integer, it will occupy 4 bytes. Now double occupies 8 bytes. So you can see x, which is an integer, can easily be assigned to y without any conversion. This is the value is getting actually inside y 10.0 gets stored. Whatever is the value getting stored, that is not important. What is important is the conversion from integer to double is happening automatically. So this particular type of automatic type conversion is also called cohesion. You can see over there, I've written over there. And in the above code, 4 byte integer value is assigned to 8 byte double value. You can see that. Now look at the explicit type conversion. In explicit type conversion, what happens? This is not done automatically. You see over there in the example, and you'll easily understand. Double x equal to 10.5. Now I can never write int y equal to x because x is of higher data type. It cannot be assigned to a variable of lower data type. Double is of 8 bytes and y is of integer, that means 4 bytes. Double cannot be assigned to integer. It will be possible loss of precision. So that is why we need to typecast it. This is called typecasting. That means I am telling Java what should be the resultant data type of the mathematical expression. So I am telling that convert it to an integer and store it. Of course, both these variables should be compatible. You cannot do int typecast to a boolean variable over there. You cannot take boolean y. So that means the data type of the variable should be compatible, number with number. So it should be kept in mind. However, when you do the typecasting, there may be a possible loss of precision, like 0.5 will never get stored in int. And now you look at the definition. Explicit type conversion is a way of converting data of one data type to a compatible another data type. It is also called typecasting or explicit casting. And you can see that this is the way Java follows the rule. From byte to short, you can easily convert it. And from left to right, you can implicitly perform type conversion. But from right to left, if you go, you have to go for typecasting or explicit type conversion. Thank you. With that, we come to the end of this video. I believe you understood this, and like the other videos, I have posted few assignments connected to this. Please complete it and post it in the WhatsApp group. Thank you.